Have you ever wondered what the entire universe is made up of? According to scientists and researchers, the material that makes up the stars, the Earth, and everything else in space that we see is normal matter. Normal matter only makes up a small portion of the universe. The remaining portion of the universe is made up of two mysterious elements that profoundly influence our universe. Dark matter, which neither emits or reflects light, makes up a large portion of the universe's mass. But just like visible matter, which exerts gravity on objects, they have all the properties, but it's dark matter. The interesting thing is that we still don't know. There is so much more that we have to learn about space. Space, all in itself, appears to be permeated by a strange force called dark energy that is tearing things apart. Now, what exactly is dark matter? Does that mean that normal and ordinary matter, such as quarks and electrons, is not made up of fundamental particles? We don't know what dark matter is. However, since we are made of atoms, we do not know what dark matter is composed of. The textbook definition is, in some cosmological theories, non-luminous material that is postulated to exist in space. It is said that it could take any of several forms, including weakly interacting particles, cold dark matter, or high-energy, randomly moving particles created soon after the Big Bang, that's hot dark matter. Are the things that we knew or read up until 30 or so years ago still true and relevant? They only make up a small portion of the narrative. Dark matter and dark energy are the two main characters. According to current estimates, only 5% of the universe is thought to be composed of ordinary matter. Dark energy makes up a whopping 68% of the universe, while dark matter makes up 27%. How do we know they exist, and what are they? Even though dark matter is not visible to our eyes, we know that such a thing exists because of how it affects natural objects like galaxies and stars. We know it exists. Dark matter is a matter that we assume to exist based on the gravitational effect it has, with one specific example. Is it true that if you look at the rotation of galaxies, which is how the discovery was actually made, you'll see that they rotate much faster than they should? If the only factor considered was the gravitational pull of the matter, then that would simply fly apart, indicating that there must be additional matter, and we refer to that as dark matter. We can use a technique called gravitational lensing to determine the location of dark matter. As the name suggests, we don't see the dark matter, but the effect it has on other planets and celestial bodies. Astronomers can observe this bending where there is no visible chunks of matter, such as stars, due to relativity's theory that massive bodies have bent the fabric of space-time. This mainly happens when dark matter is around. These observations have led researchers to discover a cosmic web of dark matter. As the universe expands, long threads of it tend to be concentrated in aliens around galaxies. In fact, it's believed to have played a crucial role in the development of the large-scale structure of the universe. However, in our universe, gravity is actually the most significant form. During the initial 10 billion years, gravity served as the chief function object, the force that put everything together. As a result, it was the gravitational pull of dark matter that actually brought matter and everything together to form galaxies, clusters of galaxies, and ultimately stars, and form solar systems like our own. Exactly what dark matter is made up of is still unknown, but there are a number of theories. Therefore, one of the major questions about dark matter is, what is it? And second, if it interacts with ordinary matter at all, it doesn't emit light, which implies that it isn't composed of atoms, because atoms emit light when you kick, tickle, or otherwise manipulate them. Consequently, it cannot be charged particles that make up this dark matter. And we've reached a point where we think it's a new kind of matter. We haven't yet discovered a new type of stable matter that is made up of particles that are left over from the Big Bang. There are a lot of experiments that are being conducted to discover and learn more about dark matter. Scientists and researchers hope to catch it as it occasionally collides with ordinary matter. This is the only time when they can fully see dark matter, but as you can guess, none of them have so far been successful. Astronomers use some of the largest telescopes in the world. They are observing the cosmos with ever greater precision to learn about where Darlene is located. This also raises the possibility that dark matter particles may just be created in earthly laboratories at the Large Hadron Collider in Switzerland, where particles are smashed together close to the speed of light. Imagine how scientists learned about the other mysterious force that is forming our universe through their research in the late 1990s. It was accidentally discovered by astronomers who were looking at a far-off supernova. That was when they noticed that the universe's expansion appeared to be accelerating. In order to describe this new enigmatic force that appeared to be pulling the universe apart, Michael Turner came up with the term dark energy. Einstein's theory of general relativity contains a possibility for very strange stuff, which we now refer to as dark energy. Now, dark energy may be the most profound scientific mystery of all time, given that the universe is expanding at an accelerating rate. Gravity pushes things apart instead of pulling them together. Early versions of Albert Einstein's theory of relativity contained the notion that the universe could grow or contract. However, Einstein always assumed that the universe has a fixed size. He manipulated his equations by adding a fixed value to make the numbers add up correctly. Only after it was established that the universe was expanding did he declare a cosmological constant, proving his equations to be correct all along. Additionally, Einstein's cosmological constant might end up explaining dark energy. Despite the fact that many theories have been put forth, no one is certain what dark energy actually is. Dark energy is not particles because we're very familiar with what it is not. We are unable to separate it into its component parts. It resembles a medium or a substance more. Dark energy, in contrast to dark matter, does not clump. It's evenly dispersed and it's uniformly distributed. Most likely is that it is simply vacuum energy, which is the energy of empty space. The vacuum is not a simple state at all, it is a very complicated state where particle and antiparticle pairs are constantly appearing and disappearing. We also believe that there must be at least one field called the Higgs field, which has a non-zero value everywhere in space. Since gravity is a component of it, the universe itself can carry energy even in the absence of actual particles. In fact, that is what happens. It's anticipated that as space expands, dark energy will increase, pushing the universe apart. What remains unknown to astronomers is it possible that the expansion's rate of acceleration will alter over time, and if so, what impact might it have? Implications. Is the rate of acceleration increasing? If so, dark energy will shatter the cosmos, galaxies, galaxy clusters, solar systems, planets, and eventually we will all be destroyed by it. It is going to tip apart everything. What will happen to our universe depends on how these two dark titans interact. Dark matter and dark energy have shifted in dominance over the course of the universe, with dark matter playing a stronger role in the early years and dark energy gaining traction more recently. If dark energy dominates, the universe may collapse in on itself in an event known as the Big Rip, whereas if dark matter dominates, the universe may explode back into existence in an event known as the Big Crunch. If neither force dramatically changes, space may just continue expanding outward indefinitely, according to cosmologists. Much is still unknown for cosmologists trying to predict the final outcome of the universe. Thank you so much for watching. Let me know your thoughts in the comment section below. Have a good day and don't forget to subscribe.